Imagine being able to see what is invisible to the naked, to peer through darkness or smoke, and instantly spot problems before they become disasters. It sounds like science fiction, doesn't it? Well, that is precisely what thermal imaging achieves, by detecting anomalies through temperature differences. It works by capturing infrared energy emitted by objects and converting it into a visual image, where hotter areas typically appear brighter or in different colors, making it easy to identify unusual heat signatures that indicate a potential issue. The fundamental principle behind thermal imaging is thermodynamics, specifically the fact that all objects above absolute zero emit thermal radiation. This radiation, invisible to the human, is part of the electromagnetic spectrum, just like visible light, but with longer wavelengths. A thermal camera contains a special lens that focuses the infrared energy onto a detector array, often made of materials like vanadium oxide or mercury-cadmium telluride. These detectors are incredibly sensitive and convert the infrared radiation into electrical signals. The camera's internal processing unit then interprets these signals, assigning different colors or shades to different temperature values, which is then displayed on a screen as a thermogram. This allows operators to visualize subtle temperature shifts that signify something out of the ordinary. For instance, if a section of an electrical circuit is overheating due to a loose connection, the thermal camera will show that area as significantly hotter than the surrounding components, indicating a problem before it causes a failure or fire. Similarly, in building inspections, a cold spot on a wall might reveal a lack of insulation or a moisture issue, while a hot spot could point to faulty wiring behind the surface. In industrial settings, these cameras can spot worn bearings in machinery or leaks in pipes by identifying localized temperature changes, providing a non-invasive way to monitor equipment health. What is particularly fascinating is that these cameras do not require any ambient light to function. They operate equally well in total darkness because they are sensing heat, not reflected light. This makes them invaluable tools in situations where visibility is compromised, such as during firefighting operations to locate hidden hot spots or in search and rescue missions at night. The ability to quickly scan large areas and immediately identify thermal signatures that deviate from the norm is what makes thermal imaging a powerful diagnostic tool, helping to prevent costly repairs and ensure safety in many high-stakes environments. Ultimately, thermal imaging provides a unique perspective on the world, translating the unseen language of heat into a visual map of potential problems. By revealing these thermal disparities, it empowers professionals to identify and address issues proactively, transforming otherwise invisible risks into actionable insights and contributing to safer, more efficient operations across countless industries.